Hello. Previously I explained how to detect edges using a suitable kernel. Today I'm going to talk about real edges because the edge I talked about previously was an ideal one. An ideal edge. So an ideal edge can never be real, and this is due to the imperfections in the optics or in the imagery system in general. So even if you have, for example, sketched an edge on a software like Microsoft Paint and print that edge out and take a picture of it, you will never get an ideal edge like this one. So what you would get instead is something that passes through some intermediate values before reaching the highest value, which is 1, right? So this is what you would get. And of course this is in continuous. In discrete, you would get something like a staircase, something like that, before reaching the value of 1. So you can have here, for example, 0.25, 0.5, 0.75, and then 1. Here you have 0. But just for the sake of simplicity, I'm gonna use the continuous form to explain the sharpness of edges. So now this is a real edge, or more close to a real edge. And what I want to do now is to consider to consider two edges to study their sharpness. So consider with me this edge that has a given slope. Let me call it alpha 1. So alpha 1 is the slope of this edge. Here I have 0, here I have 1. And the width of this edge, or the width of this transition, it is also called the width of the edge, is W1. That is how thick this edge is. So this is edge number 1. And this is edge number 2 that would have that would be wider. Zero, 1, the width is W2, and the slope is alpha 2. Now, if I plot the derivative of this edge, I would get a peak that has a magnitude of alpha 1 and the width of W1. If I do the same for edge number 2, I would get a peak that has a magnitude of alpha 2 and a width of 2, W2. Not a width of 2, W2. So now, for sharper edges, if an edge is sharp, it's going to have a higher magnitude and a smaller width. So in this case, alpha 1 is higher than alpha 2, and W1 is smaller than W2. So by these two cues, I can know which edge is sharper. So in this case, for example, the edge 1 is sharper than edge 2, and this makes sense. This makes sense because the transition from the 0 to 1 is faster than the transition from 0 to 1 in this case, because the width is smaller than the width in this case. So in this way we can compare the sharpness of two real edges.